My name's Ashnil Kumar. Please just call me Ash. That's completely fine. I'm a lecturer in the School of Biomedical Engineering at the University of Sydney. I'm also part of something called the Westmead Initiative, and I am the Assistant Deputy Director for the ARC Training Center for Innovative Bioengineering. So that means I get to do quite a lot of things, right? As a lecturer, I'm involved in teaching classes and supervising students as they go through their different degrees that they do at the university. Because I'm, at a research intensive university, I'm actually involved in quite a lot of hands-on research into creating new biomedical technologies that can be used in our society. And I also work with hospital staff, that's part of the Westmead Initiative, to solve the types of clinical problems they might encounter as part of their day-to-day work. So what is biomedical engineering? So it's actually a very broad term, really, that kind of encompasses wherever healthcare and technology intersect, right? And so when you're looking at either when you're going to a doctor or to an optometrist, there's a lot of biomedically engineered technologies that would surround you, right? So things like sensors that pick up vital signs, X-rays and CT scanners that image the human body, the computer systems that support the clinicians in the work that they do, right? Laboratory biological tests that might have been, being processed by different machines, robotic surgery. So there's a lot of different technologies that form part of biomedical engineering. And so there's a lot of interaction between lots of different fields, but a key thing is taking these technologies and applying them to a healthcare domain. So now that we know a little bit about what biomedical engineering is, and we'll go into deeper about what you might be involved in biomedical engineering if you go down that path, I thought I might talk to you a little bit about my journey in biomedical engineering, how I got to where I am, and the sorts of things I've been involved in over the years. So my journey, and this is my journey so far, started almost 2 decades ago. I'm not going to give you an exact number, so as to hide my real age. And I actually started off with a Bachelor of Software Engineering, Bachelor of Arts. It's a 5-year degree. At the time, there wasn't a specific Bachelor of Biomedical Engineering degree that I could do, right? So if I had wanted to do biomedical engineering, I would have had to do a mechanical engineering degree and then do biomedical on top of that, right? So that wasn't something that was an opportunity that was available to me at the time. So instead, what I did while I was doing my software engineering degree, I started, pulling in bits and pieces of biomedical engineering content where I could through the types of studies and electives I was doing, right? So my first year, I just got introduced to engineering. I started doing some, and so here on this slide, I've shown you a couple of the highlights of the types of things I've done, right? In my second year, I was involved in some business planning with pitching to venture capitalists. By my third year, I got really deep into technical content in my software engineering field. And then in my fourth year, based on all of the things I had done previously, all of the introductory work, the business planning, the technical content, I had the opportunity to do a project as part of my studies with a biomedical engineering company. Now, this project, was covered by a confidentiality agreement, so I really can't tell you what it involved, but it was really cool. I actually got to go to the clean rooms at this biomedical engineering company, got to see the machines that I would need to be working with as part of this project, and it was really one of the key for shaping experiences that opened me up to this career path, right? And then when I got to my final year, I decided that imaging was one of the areas I wanted to work with. So I did my final year project on a tool for cancer imaging. Specifically, I wanted to take images like these and then being able to characterize the tumor in that CT image there, saying this is how big it is, this is where it's located, it's adjacent to the chest wall, and then using that information, a clinician could possibly use it to make better decisions. Now, this sort of project, getting hands-on and working on a problem that wasn't just an assignment, but would have real-world implications was really something I found exciting. So my next step was, okay, I want to do this for my career. I want to be involved in creating new innovative solutions and then letting that be used in healthcare. And for me, this meant I actually had to go back and do more study. It required a higher degree, a PhD. And so I spent another 4 to 5 years working as a research student doing my PhD. I did my PhD project was with the Royal Prince Alfred Hospital, right? So I spent, at one stage, I spent 6 months at the hospital. And then after my 6-month placement, I used to go back very frequently to continue working on the project. But basically, I took that idea I had in my undergraduate thesis project of developing cancer imaging software, and essentially I expanded it out, right? And so within that period of my PhD, I worked on a number of different pieces of software that would possibly give different ways of looking at patient data, right? Going from looking at patient populations to looking at what groups of similar patients might look like. So if they've got one treatment works well for one patient, then perhaps it might work well for a similar patient, and then being able to personalize that to an individual patient. So that was something I found really cool. Now, because this was a gigantic project, I didn't do this by myself. I had supervisors, I had other colleagues, and we worked on these sorts of systems together, right? So that was my PhD training, right? And after that, till today, I've continued along that same pathway on working on computing systems and software solutions that will have medical applications. Particularly, we're living in a world that is rapidly being changed by AI. I'm looking at how do we apply artificial intelligence in health, right? And all of this work is being done in collaborations with hospitals. So with the Royal Prince Alfred, I'm doing projects on tumor analysis, looking at how the disease changes as the patient is treated, right? They might get treatments and all of a sudden the disease starts disappearing. It might reoccur, which means you might need to give them more of their treatment, right? With Westmead Hospital, I've been looking at skin cancer analysis, right, which is Australia's one of the largest cancers in Australia by occurrence. And then with Nepean, I've been looking at newborns and neonatal patients, right? Trying to look at, can we measure how a fetus is developing within the mother so that we can provide the mother with additional support, for example, if they need additional nutrition, etc. So that was the idea of what I've been doing, is just constantly been going to clinicians, asking them, what is it you need to help you in your work, to help you treat patients more effectively, to optimize your time. And then we've been together working on all of these different types of software systems that they can apply and use. So if what I've talked about is based on my experience, and because I had a background in software, it was all, computing and AI systems, but it's actually quite broader, right? And so you might be interested in studying biomedical engineering as well. And if you are, then I thought I might give you an idea about what you would need to get in, and then what you might learn along the way, and through that showing you what's different, right? So at the University of Sydney, I think the 2021 ATAR was 92, and the requirement was HSC 3-unit mathematics or equivalent. Now, mathematics is really important to engineering because we do a lot of modeling, understanding how cells behave. We can do a lot of those things with mathematical modeling. So mathematics is really important. Now, there are other things that can be helpful, right? So if you've done engineering studies, IPT or STD. If you've done physics, biology, obviously will be incredibly helpful, chemistry as well, right? So if you're interested in biomedical engineering, the ATAR and the mathematics requirements are the key factors we look at, but all these other things will also be incredibly helpful in your first year of study. So if you decide to do biomedical engineering, here's the types of things you might be exposed to. So there are things called foundational knowledge. And so that's basically what you need as a minimum to start operating in the biomedical domain, right? So there'll be things like cell biology, anatomy and physiology. You'll learn the basics of electrical circuits, materials science, and mechanics. Then you'll take that foundational knowledge and develop advanced technical knowledge, right? You'll start looking at mathematical modeling, looking at biomedical signals, biomedical physics, tissue engineering, different types of materials that are bioactive, right? And so all of those types of things will then you'll start looking at how do we start applying them in industry, right? How do we develop biomedical products from them? What is the regulatory framework? Because, biomedical products, we've got to go through a lot of safety testing. And then in order to develop this, we also give you the opportunity to develop not just your technical skills, apologies, helicopter flying overhead, but also professional skills by giving you the opportunities to interact with clinicians, work on projects, do thesis projects. Now, this is basically the type of thing every biomedical engineer will get to learn. But what's really cool is that everyone gets the opportunity to essentially develop specialist skills of your choice, right? So taking this and then really looking at specializing in a particular area. And so what might those specializations look like? So there's something called bionics and bioelectronics. And so that's where you're essentially merging your knowledge of biology and electronics to do all sorts of bioelectric implants. So the example is our head of school. He's one of the inventors of the bionic eye, which is essentially an implantable sensor, which essentially restores vision to the vision impaired. It's kind of like the cochlear implant it's kind of like the cochlear implant for vision, right? The other type of specialization might be things like modeling and design. Orthopedics is a really cool thing to look at, right? So helping people walk, customizing implants so that what we're doing is not just giving every patient the same implant, but giving them an orthopedic implant that might be personalized for them in order to optimize their own recovery, right? Now, the other area that we're looking at is nanoscale biotechnology, where we're looking at really, really tiny things, how different cells behave, how they move, and how they interact with other things, because based on this, you can create all sorts of new devices that take these cell properties and being able to exploit them for biomedical applications, right? And so that's another type of specialization that a lot of our students get involved in. And of course, my area, which I've talked about already, biocomputation, using all sorts of advanced computational tools to solve clinical problems, in particular, the example I gave earlier on for imaging. Now, while you're learning these technical contents, it's really important that when you're at university, you develop your network. At the University of Sydney, we've got a really active student association, SUAB, and in non-COVID times, we do a lot of in-person gatherings, networking events, and it's not just the students, we also invite industry. And this is a society that's run entirely by students, but the academics, the school staff, we're really keen on supporting this as well. So it's really important to build your network while you're at university as well. And so hopefully when COVID restrictions are lifted and you've got the opportunity to come visit us, SUAB often organizes tours so that you can come and see the new biomedical engineering facilities we've got. So you might, finish your degree. What might be the job opportunities you might have? And this is a common question we get asked. Actually, if you just look at New South Wales, there's actually a very high concentration of medtech businesses. In particular, over the last 5 to 10 years or so, we've seen increased government investment. And this isn't just in New South Wales, it's in other states in Australia and abroad as well. I think I found this article on one of the Engineers Australia newsletters, and it was talking about there's almost 500 small businesses and big companies in the biomedical sector in Australia and New Zealand. So there's a lot of industry opportunities in the big companies as well as smaller companies as well. Hospitals are also an area where biomedical engineers go and work. I've got quite a number of colleagues who are actually based at hospitals. This is Ian Craig, who's leading the biomedical engineering services at the Children's Hospital at Westmead, right? And so there's an opportunity to work in hospitals as well. Career opportunities, you can go a similar path to me, down biomedical research, developing new devices, new solutions for use in clinical care. This is my colleague, Dr. Tegan Cheng. And when she heard I was giving this talk, she said she'd be really happy to answer questions. That's her Twitter there. So if you're interested, she's a very keen supporter of people who want to find out more about biomedical engineering. And so she does quite a lot of biomedical research, particularly looking at children's orthopedics, because that's an area that's underserved compared to the adult population, right? And of course, there's opportunities to start your own company as well. And this is actually something that was recently announced just a couple of weeks ago. Two of our students, Matt and Matt, they founded their own company, Resus Right, based on their final year project. They're now doing their PhDs while also running their own company. They've recently gotten almost about $800,000 worth of funding, but their startup is valued at around 3.8 million. So there's an opportunity, if you've got cool ideas, if you've got a great team around you, to take what you've learned and follow this entrepreneur pathway as well. Now, I know I've just spent quite a lot of time talking away. So I think this hopefully has given you a brief idea of what one pathway through biomedical engineering, mine, has looked like, what biomedical engineers do, what you might learn if you do biomedical engineering, and where it might take you. Now, I've seen there's at least one question in chat, so I will get to that then, but that's it for my presentation. So I'm just going to have a quick drink, but then we'll happily answer your questions. Oh, wow. So first question is probably the toughest one to answer. What is the greatest biomedical innovation done so far in Australia and in the world as a whole? If you cannot name one, please mention few in order of importance. Now, that could get me in trouble, because every company will say that every researcher will say that their innovation is the most important. There'll be people who say that this disease grouping is the most important. So I'm not going to give anything importance, because that's very highly contextual, okay? But I will give you a couple of things that have been done so far in Australia and abroad as well. So in Australia, I think things like ResMed's CPAP machines are one of the really important innovations. I believe Colin Sullivan was one of the, Professor Colin Sullivan was one of the people who invented that. The cochlear implant, which is available worldwide, is also another very important innovation that came out of Australia. If you're looking at globally, things like the CT scanners, MRI scanners, they've won the Nobel Prize. The inventors of that have won the Nobel Prize in medicine, right, for their inventions. So those are some really important innovations that have occurred worldwide as well. Like, I guess if I were to sit here and talk about just all of the innovations that have occurred globally, we'd probably be here for months. So I think I might just move on to the next one. Okay, so the second question is a biomedical degree too specialized? In terms of employment, would it be difficult to get a job? Would it be better to take a mechatronics degree and then do a biomedical elective in fourth year? For research and development, what are the opportunities in the industry to do R&D in comparison with doing it as a research student, university research? So I might answer the second part of the question first. There's quite a lot of opportunities to do research in industry. In fact, part of our degree program, we actually have something called ESIPS, which is an engineering Sydney industry placement scheme. And as part of that, students actually get to work with a company on the research and development problem that's important to them. So there are quite a number of R&D opportunities available in industry as well. The academic research pathway is also an option, right? So in terms of in terms of the degree choice, I guess one of the things to note is back when I did it, it was very different. Nowadays, a biomedical engineering degree is not just one biomedical elective. You'll do, for example, 6 or 8 or 10, right? So it is a little bit specialized, but even within those specializations, you're actually developing fundamental skills. For example, bionics and bioelectronics, if you're doing units in those, you're still developing electronics skills, but just essentially looking at how they're applied in biological applications. Now, whether or not you choose, what degree you choose is, I guess, based on a little bit of your own interests. But we've had our biomedical engineers, who've done, for example, biocomputation type units. They have been hired by companies that are working on data analytics, right? So it's those skills are transferable. And part of, I guess, one of the things you learn at university is not just how to specialize in your area, but how do you transfer those specialist skills to other areas as well, right? So the next question is, what is involved in other career and education pathways that are related to only biomedical study rather than biomedical engineering? Okay, so that's, I guess, asking what are the other options in biomedical study. So I can answer mainly from an engineering perspective, but if you're looking for other opportunities, there are medical science degrees, right? And in fact, quite a lot of biomedical engineering students do a combined degree with medical science, and that's looking at a little bit more of the fundamentals of the scientific principles that govern anatomy, physiology, genetics, immunology, things like that. A lot of people might look at biomedical science, right, at a master's level. So that's another opportunity to go through that pathway. But you're essentially very different, I guess, degrees as well. Some of them might be 3 years, some of them might be, engineering is 4 years, unless you're doing it combined, in which case it's longer. So each of the pathways are different. They'll offer you different opportunities. One of the things with the biomedical engineering degree is that it is accredited. At least the University of Sydney ones and quite a number around Australia are accredited by Engineers Australia. Whereas if you do some other degrees, you just have to make sure that, yes, you might have done a biomedical X degree, but if it's not an accredited engineering degree, then there's a little bit of distinction between them as well. Okay, so the next question is, you mentioned earlier that at some point in your career, you required a higher degree, which is when you did your PhD. Is postgraduate study essential, or can a bachelor degree and experience also make you an employable engineer in the industry? Oh, absolutely. The vast majority of students don't go on to do a PhD. I have numerous examples of colleagues who've gone off, they've finished their undergraduate degree, started going out and working at, Cochlear, Stryker, ResMed, or other companies, right? So you don't necessarily need a PhD to work in industry. I guess for me, the career I wanted, which was really looking at, deep technological innovations, in order to be able to do that, I needed a PhD, but that was because of the very, very specific things that I wanted to do, right? But it's not a requirement to do a PhD, although it is highly encouraged because you do get to learn quite a lot of cool things and skills that you can then take out to industry as well. Okay, so the next question is, what would generally be one of the most successful career prospects or career lines after graduating? Was it mainly relative to a person's interests? And success will, you are correct, success will look very different to different people. I know some people who've finished their biomedical engineering degrees and then actually went off to work in consultancies, but using their biomedical engineering background to help the work that they're doing in their consultancy. But that's because they really enjoyed that sort of work. I've had students who've had a clear goal when they started that they wanted to go off and work for a particular company. And so they followed through in that and now are employed by that company. I've had a student who was very interested in being part of a startup. And so after graduation, they're now working with a startup developing some very cool technologies having to do in the food and nutrition area. Okay. All right. So there's a question about what would you encourage as the first step for those looking into a biomedical engineering as a career? Well, I'd probably recommend doing a degree in biomedical engineering as one of the first steps. The ways a lot of the degrees are designed in the first year, if you're quite flexible, and so you might be able to look at opportunities if you find out that biomedical engineering is not for you. But that generally is the first step. But then along the way, what you should be looking at is developing contacts with industry, with clinicians, and things like that, right? So the first step is developing your, I guess, technical skills, your qualification, but while you're doing that, also developing your own professional network in the industry you're looking to work in. So the next question is, how exactly would someone go from a bachelor's degree to working very closely in hospitals, such as the Westmead Initiative? So I can talk as an example from our the School of Biomedical Engineering at the university. We actually have a third-year unit where actually students get partnered with clinicians at hospitals to work on a project for them as part of your undergraduate unit, right? So you actually start developing contacts with clinicians in your undergraduate degree, and then use that as part of your resume if you're interested in working with hospitals later on. A lot of our students actually go and do summer placements, summer internships at hospitals. And again, that's another way of developing your link to these clinical environments. And of course, our staff are generally quite helpful in linking you up for that. Okay, a question. Would you recommend this degree to someone who doesn't like high school math? Okay, so that's a little tricky because math is quite an important part of our degree. And in second year in particular, you'll be doing a very important mathematical modeling unit. And I think you'd do a similar unit even if you're doing, for example, mechanical engineering. So yes, it's actually quite important. And if you find that you're not enjoying mathematics, some of the mathematical mathematically focused units, you'll probably have a little bit of struggle with. However, we've also had the distinction of finding when students, who didn't really like math, but then they start seeing how math gets applied to biomedical engineering problems, and all of a sudden it starts clicking, right? So that might be another thing, right? That perhaps it's an opportunity to do math in a context that motivates you. So that might be another thing to look at. Okay. So can you transfer to biomedical degree from a different degree, such as mechatronics or electrical in later years? So that's something that gets usually handled by university administration. I think first year might be a little bit easier because the later you go on, you might have units that might not map over exactly. So you might have done a subject which won't count, which means you might have to extend your degree. There is possibility, but to really answer that question, it's not easy to answer in a forum like this. It requires probably consultation with someone from university administration to help with that. The next question, does the University of Sydney offer any global exchange programs for biomedical engineering? Okay, well, at the moment, because of travel restrictions, it's not happening, but we do have a global mobility program, right? So a lot of our students are highly encouraged to go and do exchange at institutions abroad. And many of them prior to COVID were doing that. And hopefully when vaccinations are high and case numbers are low and borders open up, we'll be able to resume that in some capacity. But it is a core part of our strategy in trying to make sure that everyone has an opportunity, if they're interested, to see what opportunities abroad at other institutions might be like. Okay. Are there any other questions? Awesome. Well, I'd like to say thank you, everyone, for coming today. It's been great to sit and chat and answer your questions. I've really, it's really awesome to see so many people actually here. I hope my question, I didn't go too fast and that my answers were helpful. You can always search for me on the University of Sydney website, and my email should be listed. So if you've got questions, feel free to email me. And if I can't answer them, I'll try and forward them on to someone who can.